Hello, I'm Greg Robinson, Program Director of NASA's James Webb Space Telescope. I'm going to give you a short briefing today on the amazing science that we're going to get and the development status. And this is a follow-on to the Hubble Space Telescope, which has produced amazing science for over 30 years, and James Webb will be even more powerful. So as I mentioned, this is James Webb Space Telescope. It's a mission to seek light from the first galaxies in the universe. That gives us a lot of information on how old the universe is, how galaxies were formed, and some inference on how the universe, or when it was actually started. That helps answer the question, where did we come from? And we're going to also explore other worlds and within the our own solar system, habitable planets. Is it possible to have life similar to Earth life on some of these other planets? That answers the other question, are we alone? There are thousands of astronomers across the world that will be doing science with James Webb. And this is a NASA-led partnership with ESA, the European Space Agency, and CSA, the Canadian Space Agency. And who is James Webb? So James Webb was our second NASA administrator. He played a major role in the early human spaceflight missions of Mercury, Gemini, and Apollo. And he was a major player in some of the early science missions as well. So a couple of things I would talk about on this slide is, one is the size of the mirror itself. Hubble, 7.9 foot mirrors, and Webb is 21.3 feet. So if you could imagine the difference in size, it's tremendous. And of course, when you're doing astrophysics and you're looking back into deep space, you need really, really big telescopes to do that. And you can see the size of Webb is 72 feet, and Hubble was 44 feet, or is. But Webb is a lot lighter than Hubble because of a lot of the scientific ingenuity and engineering ingenuity in selecting certain types of materials and parts and the way that it's constructed. And of course, Hubble, if you recall, we did multiple servicing missions to keep it going. It's in low Earth orbit, and Webb will be out at Lagrange point 2, L2, which is about 1 million miles from Earth. And of course, it's going to be extremely cold, 370 degrees below 0 Fahrenheit. So here's the telescope again. The primary features, in addition to the telescope, we have some amazingly scientific instruments, more powerful than we've ever built. And they're going to take that light that the telescope actually collects from the primary mirror, transfer it to the secondary mirror, which will take that information into the inside of the spacecraft, into the instruments. And that's where the science is actually calibrated there, and we'll get those images back here on Earth. So we're going to fly on an Ariane 5 rocket. I mentioned that ESA is a partner, the European Space Agency, and they're providing the actual rocket. We're going to launch from South America, French Guiana. The launch site is in Kourou, French Guiana. And again, that's October of 2021. We're looking forward to that.
This is your telescope, an engineering marvel, an exploration powerhouse. Use it to look back in time and explore the first galaxies that formed after the Big Bang. To peer into atmospheres of planets orbiting the stars. It's your eyepiece to the uncharted, unknown, and unimagined. This is the largest, most complex, and challenging space telescope ever constructed. It will change our understanding of the universe and our place in it. The James Webb Space Telescope. Equipped with the largest primary mirror ever to be flown in space, at 6.5 meters, it's more than 6 times the size of the Hubble Space Telescope primary mirror. Webb's 4 cutting-edge infrared instruments and cameras operate at super cold temperatures. Temperatures colder than the surface of Pluto. Getting this cold is done with the help of the largest sun shield ever flown, a 5-layer, tennis court-sized sun shield that blocks heat from the sun, Earth, and Moon. Webb will be the first telescope to detect light from the most distant galaxies in the universe. These first galaxies formed about 13.5 billion years ago, only 300 or so million years after the Big Bang. Webb carries advanced technologies to tackle some of the most fundamental questions about the universe. How did the first galaxies form and evolve? Are there chemical signatures of the building blocks of life on other worlds? Is our solar system unique? Launching such a large telescope into space is an incredible engineering challenge. Fully deployed, Webb is too large to fit inside any rocket fairing. Engineers designed it to be folded, like origami, to squeeze inside the European Space Agency's 5-meter diameter Ariane 5 rocket fairing. After launch, controllers on the ground deploy Webb remotely. Deployment is an intricate ballet. For nearly 3 weeks, controllers carefully unfold Webb. After this delicate dance, Webb's golden mirrors are precisely aligned using motors behind each hexagonal mirror segment, adjusting them to form one perfect mirror. Once the instruments are fully cooled, the exploration will begin. Webb is a technological challenge like no other, born of the efforts of thousands of people across the United States, Canada, and Europe. The James Webb Space Telescope is your telescope. Use it to explore, to challenge theories, to see sights yet unseen. It's yours to unfold the beauty and mystery in the universe and our place in it.